section is about artificial intelligence applications in finance. The young demographics of the Philippines is seen as an advantage over other countries. But with the exponential advancement of artificial intelligence, transforming science fiction into reality, to what extent are we going to see jobs becoming obsolete and machines replacing humans?
Well, to answer that question, Sandra, our next speaker who will discuss this topic holds a PhD in statistics from the UCLA and has worked with data and technology for over 2 decades. The focus of his work is on developing probabilistic models for complex and stochastic systems. His specialties include artificial intelligence, machine learning, hierarchical Bayesian models, classifiers, support vector machines, and textual analysis, all words I have not seen since my statistics class in college. He has authored several papers on mathematical modeling of complex data systems with innovative analysis methods. In addition, he has developed successful solutions for a large number of clients in finance, digital advertising, sports betting, cryptocurrency, education, medical, and other industries. Prior to consulting, he conceptualized and founded several technology firms, including webclipping.com and trademarktracker.com. He currently runs a consulting firm in Hong Kong, Helios.ai, and is also developing an institutional-grade cryptocurrency exchange.
Without further ado, let us all welcome on stage Dr. Noah Silverman, founder of Helios AI Limited.
Thank you for coming out. Today I'd like to talk to you a bit about AI, and hang on guys, I need the clicker or my slides on the screen, please. Thank you so much. Okay, we're going to talk a little bit about AI, and we're going to talk about the hype and the reality. And if we have a few extra minutes, I want to give you a brief background in how this actually works and what we actually do on a day-to-day basis when we're looking at how we build and model things. But to start, I'd like to show you this picture. This is a Stiletto MC15 titanium hammer. It is the best hammer you can buy. It retails for around $268 US. You can find some discounts online. Now, we'll come back to this hammer in a minute, but I want you to remember that. So what's happening? Lately, we've been seeing AI everywhere. Every business is AI, everything is AI, every company is AI, except for the ones that are blockchain. In fact, it seems like every startup I see and everywhere I go, it's all AI or blockchain. Everything, everywhere, every website, AI, AI, AI. In fact, probably the largest growth in AI this year has been all this wonderful clip art that we now use in our presentations. Lots of pictures of robots and math formulas that don't really mean much. Now, the media's gotten obsessed with AI, and you're starting to see lots of scary headlines, right? We need to protect our income from robots, scary stories of AI gone wrong, robots are going to threaten and kill the workforce. I know Philippines has a huge call center workforce, so maybe they're all going to lose their jobs. 10 alarming examples of AI gone wild. Some robot escaped. It didn't escape. It just, the motor ran and somebody left the door open. But that doesn't make a good headline. And on and on and on. Everything's AI and scary AI. Then you go the other way. You're starting to see AI is going to make everyone healthy. This is one of my favorite photos. They've got some poor crying kid getting vaccinated. Has absolutely nothing to do with machine learning or AI, but it sure makes a nice headline and makes a nice photo. Storm damage will be saved by AI. We can find life on alien planets with AI. We can help in humanitarian crisis. Does the government regulate it? Public sector. Apparently now AI is judging a beauty contest. Beauty is no longer subjective. The machine will tell you if you're good looking. Watson was IBM's big marketing push. From some people I met off the record, told me that it was actually some of their older technology they repackaged up because management wanted to monetize it a bit, and they rebranded as Watson. It apparently was going to revolutionize healthcare, but it didn't. And then it helped design a dress for some celebrity, and it hasn't done much since. But it got a lot of hype. What does it all come to? Clickbait. So the real growth in AI has come from the internet and the media. What's happened about 10 years ago is the model of media changed, and companies started earning revenue based on advertising online, and a lot of writers and journalists get paid by how many clicks or how many views their article gets. So everyone's motivated to write about the hype and write these scary headlines and get you to click why AI is going to take your job or why that poor child getting vaccinated, AI is going to save it. It's all clickbait. In fact, it's gotten so out of hand that people have started to now mock this and make fun of it. There's a great website where the author finds correlations in things that are not there, spurious correlations, and he's got tons of these great graphs. So here's a nice example. People who drowned when they fall out of a fishing boat and the marriage rate in the state of Kentucky. Apparently, they're highly related. Consumption of margarine and the divorce rate. So I guess the takeaway here is if you want to stay married, don't eat margarine. And on and on. There's a TV show in the US called Silicon Valley. I'm not sure if people here have seen it, but it's a spoof on the Silicon Valley culture and the startup scene. And in one of the series, they wanted to develop an AI startup. They got millions in funding. There was lots of drama with the coders. At the end of the day, they made a mobile phone app called Hot Dog or Not Hot Dog that used AI. You could take a picture of something and it would tell you if it was a hot dog. Somebody actually made the app for real and put it on the App Store the other day, which I thought was funny. So we've come full circle. We've come from the media overhyping the AI so much that it's now become a bit of a joke. So what's going on? This is one of my favorite cartoons, and it's the science news cycle. Some researcher finds some small little clever something or makes some incremental improvement in machine learning or technology, and it's interesting. Now, the university PR office overhypes it because they want to get attention for their academic program. The news organization overhypes it more. The news channel, oh my God, is it scary? Is people going to die? What's going to happen? And next thing you know, your grandmother's worried about it because she saw something on the late night news. And this has become a dangerous thing. Now, as a bit of a tangent, this is what I do for a living. We develop machine learning and AI model for businesses and develop solutions, but we work with real problems and real data and real models. And as an investment community, I hear more and more people in your space getting flooded with either startups looking for funding or people trying to sell you products or promising to get better returns for your hedge fund. And today, it's a bit of a cautionary tale in that most of what you're seeing and hearing is hype and very little of it has substance. There is good stuff out there, but you need to be careful. The general takeaway message is don't believe the hype, but do pay attention to the technology and do invest in underlying value, but be very careful about the hype. And the hypes come from this perfect storm of journalists, an overeager industry, and lots of young, eager kids with copy-paste tools. So much of the AI is copy-paste tools. Now, Arthur C. Clarke, who was a science fiction writer, has this great quote, which is, any sufficiently advanced technology is indistinguishable from magic. And here's where the challenge is. For people who are not experts in machine learning and don't have a background in mathematics, and I know from speaking to some people today, we do have some actuaries in the crowd who know math and some people who have studied some coding and software, they get it. For a lot of investment people in the general public, they don't. So this all looks like magic, and it's not. Back to our hammer. Don't forget the hammer. We're going to come back to that. Now, when we model things, I like to look at the concept of quantifying uncertainty. If things were certain, it's algebra. A plus B equals C. You throw it in an Excel spreadsheet, you have an answer. How many dollars should I invest in this asset? How should I balance a portfolio? What's the right insurance policy for a particular position? If it's deterministic, it's easy. When it's uncertain, you have something that looks like this, and you think, I don't know what to do. I need to make a decision. Well, from my perspective, this is not uncertainty. Albert Einstein famously said, God does not play dice with the universe, arguing that things are not that random. John Ford, who was a mathematician, has a great quote. It says, God does play dice with the universe, but they're loaded dice, and we can find out what rules they are loaded with and how we can use them. And that's very much my perspective. The world is random, the world is uncertain, but we can learn from this. And we can use math, and we can use software, and we can use technology to understand this uncertainty and this noise. So for me, I don't see that cloudy noise of dots that looks like this. I see uncertainty more like the deck of cards and the uncertainty of my clicker that looks like this. Sure, which card you're going to get next is random, but we know something. There's 4 suits, there's 13 cards per suit, there's 52 cards in a deck. So yes, it's uncertain, but there's some shape there. Now, we don't need the math. We need to understand the tools. And I'm going to start with a very, very basic introduction to some of the rough tools we use. There are no tests on this, and for those of you that had this in school, I apologize. Briefly, by show of hands, who here uses Excel at work? Just about everybody, right? Who's used solver or the goal seek function in Excel? Okay, now we're going to rebrand that as an AI solution, modernizing finance, and I'm going to charge you 10 times the price. But that's what's happening. So what do we do? Generally in this industry, we're knowledge workers, right? No one here has a shovel. No one's doing heavy labor or construction. We make decisions, right? We have decisions to make. We either want to increase something like a profit or customer satisfaction, or we want to decrease some cost, some error, some risk, default on a loan, right? We have jobs to do. So we have decisions to make and jobs to be done. And we have data, we have people, we have business process, and we have money and resources. And this is the tangible view, not the hype and the robots. So let's talk about some of the things I do. Regression. Classic linear regression, which I'm sure many of you have seen. You have points on a graph, X and Y. Maybe we're modeling, I thought about this morning, how many people will have breakfast this morning? Well, it's probably some function of how many guests stay in the hotel. Great. Now, as you get more and more uncertain, well, sure, you still have that line, but there's noise in there. And the key to the whole thing is understanding the noise, to understanding the uncertainty. In fact, I would argue that it's more important than the line, knowing where it doesn't fit. It can get worse, or you can get a weird situation like this where there's actually two different patterns in there, and you need to understand that. So we use software tools to find this, and this is very old. The math for this is 60, 70 years old. But if you wrap a little software package and put it on a dashboard, you can sell this as AI. So this is regression. We're trying to look at some number as dependent on some other number. You can do it in multiple dimensions. In fact, because of the math, you can have as many inputs and dimensions as you want. You can project it into a nonlinear space and have all sorts of interesting curves. Doesn't matter for this talk. The next thing we look at is classification. Classification is true or false, yes or no. Will the loan default or not? Will the company bankrupt or not? Will the patient live or die? Is this a photo of a hot dog, yes or no? Is it a photo of a cat? That kind of thing. Now, classification is simply breaking things into two groups. Yes and no. You might have three groups. You might have multiple dimensions and multiple groups, but it's the same thing. You're grouping things into categories. Now, this is a cute little comic, but there's an interesting point I want to illustrate here. We have three photos, right? We have a cat, a dog, and a bear. Now, all these software tools and all these AI companies do machine vision and machine learning. Self-driving cars all rely on machine vision. Is that a pedestrian? Is it a stop sign? Is there open road I can drive faster? It's decisions. But if you'll notice here, what we have for each picture is a probability, right? For the cat, it's an 80% chance it's a cat, 15% that it's a dog, and 5% it's a bear. Of course, the probability is summed to 1 because it needs to be something. But the important part to understand is a probability. So when the machine learning model says to you, yes, that's a picture of a cat, well, it's really only 80% confident. So you might want to think about what do you do the other 20% of the time? And are you even aware of that? And is the software tool even showing that to you? So uncertainty is the key to the whole thing. Now, the next level, and this has gotten a lot of buzz in the last year, is something called deep learning. All the new machine learning or machine vision projects are based on deep learning. Things like Alexa, which do voice recognition, is based on deep learning. Deep learning is an old idea that's become recently popular. What happened in the 1940s and 50s is scientists were trying to understand how does the human brain work and how does the human brain learn. And they realized that we have cells, and the cells communicate with little electronic signals. They send little pulses to each other. And a cell takes all the pulses that come into it, and if the pulses add up to a strong enough electrical signal, then that cell sends a pulse out to the next cell down the path. And they modeled that, and they called it a perceptron, which was, I guess, a play on the word perception. We now do this with math. It's a mathematical representation of what a cell would be. And this model, depending on which resource you look at, was invented around the late 40s, early 50s. And it's just a theory. We have some inputs with some weights. We turn the crank on a little math formula, and we get an output. Now, what's interesting is you can chain them together. And this used to be called a neural network. I'm sure those of you who were around in the 80s have heard the term. Each of those circles represents one of these little math formulas. Each of these gray lines between them is a weight that you learned. So every cell is inputting every cell next to it. And at the end, you have your output. And what you do is you take a bunch of data that's labeled where you know what the answer is, and you run it through this thing with a bunch of math, and you say, okay, what weights on all those gray lines will best predict my output? Okay, good, I've built a neural net model. Now, if you stack a bunch of these layers together so that it's deep, it's now called deep learning, and your startup can raise much more money because that's a hot, trendy term. But deep learning is a neural net based on a perceptron from the late 40s, early 50s. It's extremely, extremely good for computer vision. When you're recognizing photographs of things, it's fantastic. It's also really, really good with speech. For unstructured data, it's great. Now, there's been a trend recently of trying to use this in finance, where people are thinking, well, wait a minute. For the input, what if I have the price of a stock every 5 minutes? Or what if I get clever and use a Bollinger Band or some technical indicator or an RSI or some huge combination of those, and I crank those through the deep learning engine, tell me what the price of the stock will be an hour from now so I can trade on it. Inevitably, those fail. They almost never work. Or if they do work, it was in some strange little exception where you got lucky. But if you're doing financial advising, you'll see more and more of these AI-driven trading models, and if they're based on some kind of deep learning, I would be very, very cautious. Because the problem with this is you don't know what's happening inside the black box. In general, with modeling, we have things that are interpretable and uninterpretable. This is an uninterpretable model, meaning it's a bunch of these, could be thousands of these little math formulas inside. You're getting an answer that you've tuned the model to, but you have no idea how important the inputs are. You have no idea if some input changes, how that changes the output. It's completely opaque. And from my perspective, in business, especially in finance, that's very, very dangerous because you don't understand what's affecting the system, and you're making financial decisions based on that. That's risky. So what do? We're looking at probabilities. Probabilities have to come between 0 and 1. So this is an example of what's called a logit curve, where you take a math formula, you squeeze it through something called a logit, and you get between 0 and 1 out. So you can use this for machine learning. And in fact, all of this is based on a logit at the end, on the green square at the end. Now, how do we do that? Well, we have a simple formula. This is a very, very simple example I just stole from Wikipedia, where we have a quadratic equation. 4x cubed, 2x squared, 3x plus 1. Now, the x's could be anything. If it's breakfast in the hotel, it could be the temperature outside, the number of people attending a conference, maybe the average age of the guest in the hotel, the ratio of male to female, whatever you can think of. But how important are they? The 4, 2, 3, and 1, you don't know. You have to learn that using mathematics. And if it's simple regression like this, you can do some simple algebra or calculus, and the answer is very quick. If you have a very complex formula with lots of interacting systems and hundreds of variables, there's no simple math. So you need to learn those coefficients or those weights. And that's really all this machine learning is, and all this AI comes down to, is learning the weights in whatever model you've come up with. And there are some old methods that work very, very well. There are some newer techniques that are good. And what we're seeing a lot of are old methods with new hardware. Computers have gotten much, much faster, and hard drives have gotten much, much cheaper. So we can use a lot of this traditional mathematics and just do it. Something that might have taken 5 years of the computer crunching now can be done in a minute and a half on your cell phone, and that's fantastic. So a lot of the AI hype and AI revolution you're seeing is simply traditional models and traditional mathematics being done faster and more efficiently. So how do we do this? Well, we start almost from a business consulting perspective. We define the problem. Whenever I visit a client, the first thing I ask them is, what's your problem? And I don't mean that in an offensive way, but what are you trying to do? Are you trying to improve some process? Are you trying to save money? A recent client of mine is a construction firm in India, and they had problems meeting some budgets. Turns out it was productivity of a labor crew on a construction site, but they have thousands of them across India, all with different conditions. So how do they improve productivity of the labor crew? Well, then what data are available? And that's significant. Do you have any data? Is there more data you can get? Is there data you can buy? Is there a better data collection process? Or do you have tons of data siloed in some antique database that's impossible to get to that you need to clean up? You know, what's the data? And then for me, and this is where it starts to get fun, is really where art meets science. It's creating a model of the world. How do we think the data in this problem in this world works? And for the silly example of breakfast at the hotel, what's going to affect how many people have breakfast? Well, maybe did the guests get in, how many people arrived really late last night? Are they going to sleep through breakfast? Maybe conference attendees are going to stay around the hotel, so they're a little more likely to have breakfast. If there are tourists, they're more likely to leave the hotel to go out and do stuff, so they're less likely to buy breakfast. Maybe lots of kids aren't going to have breakfast. People who are a little bit older will. So you can start to theorize this, and you start to experiment with the data and learn where the relationships are and how creative are you in modeling this world. Then we need to decide what's called a loss function. How do I know if my model's right? How do I know if I'm any good? Well, for breakfast, maybe it's simple. You know, how many people did I predict have breakfast? How right was I? But is it the number of people I'm wrong, or is it the percentage that I'm wrong? Or is it somewhere in between? Or maybe I'm the guy that sells eggs to the hotel. So I need to know how many eggs the hotel's going to buy for me next week so I can plan with the farmers accordingly. So my loss function should be designed around egg usage. I don't know. So you choose a loss function. Then you've got this complicated formula. You have some model of the world, and you think, uh-oh, I need to fit all those weights and coefficients. Well, which mathematical method will I use? There are some standard. There are some new ones. What kind of hardware do you have? How long? Is this something you can take days to fit? Do you need an answer in a half a second because it's a live trading engine? What are you doing with it? Then you turn the crank and you fit this thing, and you learn the model, and you see how you did. And you might go back to step 3 and repeat a few times. This is what machine learning actually looks like. It's not crazy robots and people losing jobs and spaceships. It's pretty fundamental, basic science. Of course, the other side of that is, what do you do with the answer? How do you represent the result? Do you email a report to someone? Is it a dashboard that your staff needs to use? Is it some software or computer system that just does the work automatically? What are you going to do with this? And then finally, and to me, the most interesting part is the decisions under uncertainty. If I tell you between 150 and 218 people will have breakfast tomorrow, that's our prediction, well, so what? What do you do with it? Do you buy extra food and risk the food spoiling? Do you not buy enough food and risk people going hungry? Do you buy some of the more expensive food and less of the other foods? What decisions do you make when there's uncertainty in your model and your output? And there's some very smart things you can do with that, and there's a lot of interesting methods. The classic example in finance is a hedge. If you have a curve of the value of some asset or the probability of a firm going bankrupt next quarter, well, maybe I want to short some shares. Maybe I want to take an option. Maybe I want to buy some insurance against a default or do a swap on a credit rate to hedge out the risky part of the uncertainty so that I can benefit from the profit. But understanding how to do that and how to work with it becomes a very interesting area. In fact, it's an entirely unique field of study. You could probably, at this point, go get a doctorate just in decisions under uncertainty, and there are textbooks on this and papers and conferences on this. Interesting stuff. So an example, it's a paper I wrote a while ago, just to show you how this thought process works, on digital advertising. We were looking at, for trade schools online, they had nursing programs. They were buying ads on Google, and ads on Google, you pay every time someone clicks your ad. Doesn't mean they're going to buy the product, it just means they clicked your ad. So what do you want to advertise, where, to whom, and how much do you want to pay for a click? So we theorized that you have things like the length of the query, whether the city was mentioned, whether the degree was mentioned, the position on the page, the branding, whether somebody searched for specific brands. We had all these different inputs, and we had no idea. So we started to map things out, and we create formulas, something times the position of the ad, something times the click-through rate, something with the cost per click, city, state, brand, etc. And then we have to use mathematics to fit this model and figure out what do we do with it. So this is an example in a real-world case of how we did it. Here's another example, and this is not, well, uncertainty in the microphone too. This is not my model, but here's an example of something in healthcare where you're looking at heart disease. You have all sorts of inputs, you have outputs of different tests, and you're trying to predict a probability of that person having heart disease or the probability of them dying or having a serious medical complication. But you can start to model this out and start to fit the coefficients. The concept to take away from this is that AI and machine learning is not magic, that there's a structure beneath it, and a lot of it boils down to creating a model and fitting the coefficients to the model as you go. Now, you can do clever things with it. This was a headline I saw a few months ago. Shanghai has a robot bank. Really, if you get through all the hype, this thing's an ATM on wheels. It does all the same things an ATM already does on almost any corner bank you'd find here, but because a little machine sees you as a person and it rolls up to you with a touch screen, it's now AI in a bank. An example of something good, good is a relative term, but something successful with AI is China's SenseTime company. They've developed systems that do recognition of people extremely accurately. In fact, now if you jaywalk in China and you're a citizen, facial recognition will spot you and they will mail you your citation. No police officer necessary. So they've actually gotten their machine learning and facial recognition good enough that they can do this. Now, what's happening is you're seeing this hype, right? Data goes into what I call microwave cooking, which is copy and paste some standard tools. You add a little fairy dust, you get a really good marketing department, and you've got an AI company that you go and raise money for. In fact, this actually was a real show in the US, but a lot of these AI startups are microwave cooking, like China's first AI bank. It's an ATM on wheels. But you take a pretty standard robot that rolls around and you stick a touch screen on it that's connected to an ATM, magically you've now microwave cooked AI. I can take the sauce from one microwave dinner, the noodles from another, the vegetables from a third. I can steam this one for a minute, take it out, rotate it, cover. I can do all sorts of clever things. I'm still cooking with a microwave. And this is the microwave most people use. In the programming language of Python, there's something called the scikit-learn, Science Kit for Learning. And this is literally a flowchart of what different functions and pieces of the library you can plug in based on what kind of data you have. This is online. It's a standard PDF. And 99% of the AI companies and startups out there you see are just using this thing. And there's nothing wrong with it, but they're not innovating. There's no magic there. So I would be questioning the value of their company or the value of their intellectual property if all they've done was run some stuff through this. There was a great article someone published online that said if you're doing deep learning or models with the Python scikit learning, you are not an AI scientist, you are not a machine learning expert. You've got 11 lines of software code that you've copy and pasted. This is it. So no big deal. Now, briefly, I know everyone here is in finance, and the two questions I get the most often, and I hope no one asks this afterwards, are depending on what your role is, what company should our fund invest in that's AI-based, or what AI tools can I use to get a better return on my fund or portfolio? And my answer is neither. Don't. What do we do with AI, right? What are the tools? Well, front office, you've got some client service portals, you've got onboarding tools to make it more efficient, maybe some relationship management tools, could be helpful, right? We've got middle office, you can rebalance portfolios, risk profiles of clients, there's some nice compliance tools, performance analysis, and back office, where a lot of the hype is algorithmic trading, order routing, account aggregation, risk exposure, clearing and settlement, this type of stuff. And these are all areas where there are some innovation in tools. Now, the three biggest trends this year are chatbots, Robo Advisors, and algorithmic trading. Chatbots, bit of a sore subject because in Hong Kong, every other startup is a chatbot. And speaking of microwave cooking, 99% of these are based on about 5 different software toolkits that everyone downloads and just plugs in a few small pieces of their own. Any of us could sit down after this talk, and by dinner time, we could have a chatbot startup because you're not doing anything. Alexa is a very, very sophisticated chatbot that does nothing impressive. Alexa does text to speech, and then speech to text, and then it looks that text up in a little file like this and gives you an answer. It has classes weather. If you ask any of these questions, it knows you're asking about the weather, and it goes to Google and looks up the weather and speaks the output. Or greeting, or you want to play some music. There's just predefined little lists of these things, and that's it. But Amazon won't tell you that because it doesn't sell units. It's much better to say they've got AI. Now, Robo Advisors are the other hot area. And really, it's not that much different than a chatbot. Most Robo Advisors are using modern portfolio theory, which I'm sure if you've done the CFA exam, it's on there somewhere. An MPT was developed in the 1980s, and it's nothing special. And I would almost argue that it's out of date. There are much better ways to balance portfolios of assets now. So what people have done was take pretty boring standard MPT, and they've wrapped a nice little front-end user interface around it, and they're selling it as a robo-advisor and getting a bunch of hype. In fact, if you look here, 2% of the robo-advisors, 2.3% are actually doing full-scale optimization. Everything else is doing some pretty standard off-the-shelf stuff. So for those of you who are financial advisors, don't worry. Your jobs are not at risk, at least not from these robo-advisors. Now, algorithmic trading is somewhere where you're seeing a lot of growth. Some people call it AI, some people call it machine learning, but using mathematics to model and trade in the market is interesting, and there is some growth there if you have that kind of firm. So here are a few areas of algorithmic trading, and I'm running a little short on time, so I'm going to just quickly go through them. But technical analysis, which you can quote me on this, is the astrology of finance. Market microstructure, market making, arbitrage, portfolio rebalancing, and so on. These are all areas that are ripe and interesting for mathematics and machine learning. But to wrap up, I'm sure you all remember on the left these tabloids. In the US, they always sell them at the supermarket counter or the 7-Eleven. I'm sure it's similar here. Now, if you look at the picture on the right, please realize that these are the same thing. It's just a tabloid trying to get some hype and trying to get your attention. And I want to add one more last thing that was not part of this talk, but I realized I've got 1 minute left, and that's blockchain. Since I put together these slides, blockchain is also the most overhyped, overused thing in the space. If you squint your eyes on your browser and replace the word blockchain with Excel spreadsheet, 99% of these startups work the same. I'll leave you with my simple test. There are 3 rules if any business needs a blockchain. And you can check these, and 99% of these businesses fail. Do you need a database, right? Are there multiple people writing to the database? If there's only one person writing or one party writing, you don't need a blockchain. Do the multiple writers trust each other? If husband and wife are both writing, or 2 business partners are both writing, you have trust. So you have to have multiple people writing who don't trust each other. And what about a third-party trust solution, as in escrow when you do real estate? Do you have that? Well, then you don't need a blockchain. So if you have multiple writers, they don't trust each other, and there's no third party to manage accountability, maybe you need a blockchain. But more often than not, some nice Oracle or IBM standard SQL database will do almost everything these blockchain companies do. Blockchain isn't magic. Blockchain's a ledger, and it's a very nice ledger with some wonderful properties, but very much like these tabloids, now that they're running out of things to write about AI, they're now overhyping everything about blockchain. And really, that's my takeaway message. That's all I have for today, but I think we have time for some Q&A afterwards. Thank you.
Thank you very much, Dr. Silverman. Yes, please. Please stay on stage. We'll have a moderator. It's very interesting insight because I used to study artificial intelligence and take a look at all these heuristics and neural networks. It brings me back to my college days. And I figured one of the areas that I was really looking forward to for artificial intelligence is if we could have an artificial intelligence program, it can actually predict weather with 100% certainty already by tomorrow. Meaning, we probably have a very robust meteorological historical data, humidity, temperature, and everything. And I thought by now we could actually tell how much rainfall we'd have by tomorrow, because it will definitely help for someone like me with young children so that our government can finally say when there will be classes and no classes. I think people here with young children can relate because they can never get the prediction right.
Aware of the weather derivatives market?
The weather-driven market?
Weather derivatives.
Yes. Oh, yes. You predict the amount of rainfall and sunshine so that you could sell derivatives to farmers and tell them how much crop insurance to get, how much rainfall they're going to get for the potato farms, etc.
There's now a company, I think out of the UK, that's doing this almost as an online gambling type of thing. You can bet $100 US how many centimeters of rain will happen next week, or what the weather will be, or the temperature will be.
Right.
But, no one's predicting it well yet.
Because here sometimes I feel our local government officials, they just put their finger up to the sky and say, okay, I think it's going to rain today. We're going to suspend classes. And it's perfect weather.
There's a little better math than that.
All right, there you have it, ladies and gentlemen. Don't believe the hype, but pay attention to the technology. May we please have on stage Mr. Nichelle Gaba, CFA, co-founder of Philippine Digital Asset Exchange, to moderate the Q&A session.
Well, you can build one.
Sure, why not?
Don't believe the hype. It's very interesting that you were talking about applications in finance. I think that's the most relevant for all the people here today. I understand most of the audience are either charter holders or works for a financial institution. Maybe we can start with what you talked about, Robo Advisory. What do you think Robo Advisory does in the current ecosystem, and where do you think it will go? I understand it might not replace jobs, but are there any existing processes that Robo Advisory can optimize for us?
Good question. And to start, a disclaimer, I have never used a robo-advisor, so I'm not familiar with the current product offerings. In general, for that category, what do you do as a person, right? You're interviewing a client, you're understanding their situation as far as finances, family, employment, taste for risk. You're grouping them into some category and then making some decisions on what to do with their assets and some allocation accordingly. A lot of that can be done by software. And if you're in a service business, where that helps is saving time and being more efficient. You may have a whole category of customers or clients where it's not worth spending a lot of time or human element because, to be honest, they don't generate enough fees. They're not profitable enough for you as an advisor. And it may be that a lot of them have very simple needs or simple situations, so software can handle that very, very well, do pretty much what you would have done anyway. And then you can focus on the more complex cases that really need your specialized skills.
So I suppose in a way, we can offer services to lower tiers of clients. Whereas
Exactly.
now we have high minimum balances to support the level of service.
Exactly.
What about the astrology of finance? Let's talk about technical analysis. I myself have never done TA. Maybe conceptually I'm a little bit familiar, and it's very rules-based. Are we seeing a lot of that in the AI space? People who create AI-based technical traders?
Well, technical analysis has been around forever. People used to call them chartists. And people are always looking for patterns and trends in the history of prices. And there are things like head and shoulders and RSIs and moving averages and MACDs. And people keep inventing new ones. In academia, people have always looked at these and nothing ever holds up. If you come up with enough of these models and you crank enough historical data, you'll find something historically to fit. Something will always fit in the past. And the joke is it all works until it doesn't. And it's very much like astrology, where you can sort of explain away anything. Oh, see, well, this didn't work that one time because there was this odd whatever. But under rigorous scientific protocols, none of that stuff holds up. But most people don't know that. So what you're seeing in the AI space is kids are taking that copy-paste toolkit that I showed on the screen, and they're taking some pretty standard technical indicators. There are copy-paste tools to create them, and kind of doing a mashup of the two together, and now they have a technical analysis-based trading tool that sounds really sexy, but it won't work.
Is this something that Helios does? Maybe you can talk a bit about what you and your firm does at Helios.
Well, we develop bespoke solutions on a case-by-case basis for each client, very much like a mercenary. We come in and solve a specific hard problem. For finance or trading, I like to look at market microstructure and things like order routing and things like cross-exchange arbitrage and efficiency in markets. So we look at things in a slightly different perspective and develop tools in that way.
When you say cross-markets arbitrage, you mean buying low, sell high across jurisdictions. You've done automations in that?
Sure. From my perspective, a lot of the interesting places to generate profit are done fairly quickly. And you might see an asset trading at one price in one market and a different price in another market, and that window may be open for a small amount of time. Personally, I'm very enamored with market microstructure, looking at the flow of orders into an order book, if you have a multi-tiered limit order book, and understanding the frequency of arrivals and cancel rates of different orders and modeling probabilities of small price changes within that time frame. But that's going to get way too technical for this group.
Okay. One of the things that probably me and my colleagues have heard a lot about before is algorithmic trading. I'm not sure if you heard of this, but there was a flash crash some time back. And the consensus was it was a result of algorithmic trading and high-frequency traders driving the price down because orders were rules-based and they were getting triggered as the price was going down. do you see us facing more systemic risk because of these AI-based trading tools?
I don't think we'll have systemic risk. Most of the exchanges now have circuit breakers, and most of the programmers developing AI solutions learn their lesson by watching the other guys make a mistake. If anything, I would argue that the algorithmic trading makes the markets more efficient. In fact, in theory, if you get rid of all of the inefficiency, then you wind up with a market that's you've done true price discovery and have priced in any potential risk or any potential friction.
Here at the CFA Society, we're a very ethical bunch. We had to pass ethics in all 3 levels of the exams. Let's talk about ethics. Do you think that, well, first of all, what are the ethical implications, in your view, of applying AI to the services industry or to something like the financial services industry? You can go as broad or as specific as you want.
Well, when it comes to service-based, I think the ethics revolve around disclosure, letting the client know we use our software tool to manage your position or to give you advice versus a person. Some clients might actually prefer the software tool, some clients may not. But I think disclosure is the key.
What about in broader applications of AI? I read a couple of months ago that there were accidents related to self-driving cars. Maybe I think it was the perception module that was off. How do you think we should look at that from an ethical standpoint?
I'm not sure ethics is the right answer. I assume that anybody developing this tech is obviously looking out for human safety. At least that should be one of the components of the model. Now, when you mention self-driving car, the more interesting question to me is liability. If a self-driving car hits a pedestrian and injures them, who's responsible? Is it the owner of the car, the hardware maker, the software maker, Google, who designed some part of the vision system? Who's liable? And that is partly what's slowing development, is everyone's very scared of that risk.
I think we're running out of time, but we have a few questions. From Ralph, AI in the long term will cause efficiencies to businesses. With this, there will be a trade-off between process efficiency and keeping manpower for operations. What do you think should corporations do, both long-term and short-term, to balance process improvements with jobs of employees?
That's a good question. And I'll cover this quickly because we are short on time. Depends on what you believe the role of a corporation is. Is it strictly to make profit no matter what? Or is it as a service to the employees to create a community and create jobs? And I think you'll have to make a management decision accordingly. I'm of the opinion that you should let the AI and machine learning do as much as possible, and there will always be roles for humans, and you'll find other places for them, but companies need to evolve.
Got it. From Kate, what are your metrics and tips for people to be able to separate companies that are just mostly hype versus those with real value? So it goes back to your most commonly asked question, what should we invest in?
It's a good question, Kate. I would try to understand what the core technology is. Did they innovate new mathematics? Is it new forms of data collection? Is it a new hardware sensor? Are they using some copy-paste toolkit? I'd want to dig in a bit and do some diligence on what this actual AI engine that they've based it on is and try to understand that.
And last question, I think also from Kate. We see AI disrupting investing and financial management. What trends and what roles of AI can you see being played in more traditional banking products given stringent regulations and KYC processes? So I suppose in the broad regulatory environment, what do you think that AI can disrupt? I think you touched a bit on it earlier.
I do know I'm advising the regulatory arm of one of the governments in Asia, and I can't say whom, that they're starting to use AI looking for compliance risk, meaning identifying parties that have not broken the law yet but are more likely to, and then when they apply for licenses, watching them a little bit closer. It's also looking for patterns in AML, so that somebody might pass a traditional KYC or AML check, but the software can then reach in and say, hey, wait a minute, there's some relationship that you as a human didn't see that there may be some money laundering issues. You need to look a little bit deeper. So AI is making the regulatory environment a bit more thorough.
Looks like we have a lot to look forward to in every facet of financial services. Noah, thank you very much for coming to Manila.
Thank you.
I think